Just last month, a spacecraft was packed into the nose cone of an Ariane 5 rocket.
3, 2, 1, top!
Its launch was the start of a 7-year journey of over 8 billion kilometers and 9 planetary flybys. The spacecraft's name? Bepi-Colombo. Its destination? Mercury. This evening, we investigate what this spacecraft hopes to discover when it gets there. Because Mercury is one strange rock. Welcome to the sky at night. Good evening. We're here at the Science Museum, and this is a full-scale model of the spacecraft Bepi-Colombo.
This model was used to test the spacecraft before its launch, tests that were vital, because its twin is not only on a 7-year journey through the solar system, it's going to a dangerous destination. Tonight, we find out how this joint mission between the European and Japanese space agencies was built, and how it will cope with the journey.
We have to be able to get it to Mercury, which is the most difficult place to reach in the solar system, and we have to make sure it survives when it gets there.
We're also taking a look at the science mission, because on arrival, the spacecraft will split into 2 probes that will orbit Mercury. Bepi-Colombo is on a mission to investigate an intriguing planet, one that's key to understanding the formation of our solar system.
Because we still don't have the answers to 2 big questions. How does it survive so close to the sun? And how did it come into existence?
Did Mercury form in the location that it's currently in, or has it migrated from somewhere else?
The data Bepi sends back could also have ramifications for not only Mercury, but the whole solar system.
It's going to be absolutely transformative for our understanding of the formation and the evolution of the entire planetary system.
Mercury is the innermost planet in our solar system, and it's also the smallest, just over half as big again as the Moon. It moves across the sky faster than any other planet, completing 1 orbit around the Sun in just under 88 days. It's also unique because of the way it rotates. Mathematician Giuseppe or Bepi-Colombo was the first to calculate that Mercury rotates on its axis exactly 3 times for every 2 orbits that it makes around the Sun. What that means is that you'd have to wait 2 years between sunrises on Mercury. And, being so close to the Sun, its daytime surface temperature can reach upwards of 400 degrees Celsius. Not only that, there's evidence that the planet is littered with volcanoes, has shrunk in the past, and is still shrinking today. And so even at first glance, Mercury is an unusual planet. To find out what we know about Mercury from past missions, I caught up with planetary geologist Dave Rothery.
Well, the first spacecraft was Mariner 10. It flew by the planet 3 times in the early 70s. And it was just a flyby, so it didn't stay close to the hot planet for long. It showed us an airless body. It's very heavily cratered, like the Moon. But what we couldn't tell with Mariner 10 was these plains, these rolling plains here, are they volcanic or what? Now we've had the next spacecraft there, NASA's Messenger, from 2011 to 2015 in orbit about the planet. We're certain that almost all these plains are volcanic lava flows. This is the largest impact basin on the planet. It's the Caloris Basin. It's 1,500 kilometers from side to side. It's filled with, in this exaggerated color view, red volcanic lavas. And right over here, If I show you a close-up view of that,
Okay.
the red spots are stuff thrown out from volcanic explosions that have blasted holes in the ground. There's the rather complex-shaped hole in the middle of this red spot.
So this is like a crater of a Mercury, a volcanic,
It's a
volcano.
volcanic explosion crater, but it's not a simple crater. It's a very
So we've zoomed in
complex.
again.
I've
here.
zoomed in just in black and white now. Here's one end of it. This is the oldest part of it. There was a volcanic explosion here, then one here, then one here, then these were blasted out. This is 30 kilometres across and a couple of kilometres deep. It's a big hole in the ground. The floor of the basin is 3.1 billion years old. The volcanic explosions have to be younger than that.
Messenger revealed Mercury's long volcanic history, and evidence from those explosive events suggests that Mercury hasn't always lived so close to the Sun.
It's telling us if we're having a volcanic explosion, it's not just magma rising towards the surface, it's magma that's either charged up with gas or that's encountering something in the Mercury subsurface that's rich in gassy material that can drive an explosion. Messenger showed us that it is a volatile rich planet, far more than we expected.
So why does it matter that Mercury may be rich in volatiles? What does that tell us about the story of the solar system?
Well, it tells us that Mercury doesn't fit. If it formed this close to the Sun, it shouldn't have a large burden of volatile rich material.
Because it's just too hot.
It's too hot, yeah, exactly. So maybe Mercury formed somewhere out beyond the orbit of Mars and migrated inwards. Now that used to be pretty
heresy, more or less.
unbelievable.
Yeah.
But we are seriously talking, now we've seen exoplanetary systems, about in the early stages of planetary formation that planets will migrate inwards or outwards from their star as they're exchanging momentum with the nebula gas and so on. So maybe the bodies that formed Mercury formed further out and migrated inwards.
But it wasn't just the evidence of Mercury's possible migration that Dave wanted to show me, but geological features that tell us that the planet is shrinking.
So this looks like a dramatic feature when we look down on it like this. What would that be like if you were standing on the surface? How big a cliff would we be staring at?
They do look dramatic, don't they? The sun is quite low in the sky, accentuating it. This particular escarpment, it extends across the surface for a couple of 100 kilometres. This bit here is about 2 or 3 kilometres high, but it's not a cliff. The slope is 20, maybe 30 degrees.
Okay. So it's an annoying long hike rather than
It'll be a long
mountain
hike to get up it, but they're not as steep as cliffs. They're escarpments. We call them lobate scarps,
Right.
scarps that wander around. Those showed us that the planet is contracting. It's cooling down,
Right.
losing heat. So over the past 3 billion years, the planet had contracted by about 7 kilometres in radius.
That feels surprising to me. Is this something that planets just do?
The Earth has probably contracted by more than that over time, but because the Earth's resurfacing itself with plate tectonics, that shrinkage doesn't accumulate as a scar on the surface, but Mercury's not recycling its surface.
So this is a big feature, and it's telling us this dramatic story about a shrinking planet.
Absolutely.
How will Bepi-Colombo help us understand Mercury?
Bepi-Colombo is going to get high-resolution stereoscopic imaging of more of the surface than Messenger did. I'm a volcanologist. I want to peer inside the volcanoes, and I want to know if they were all 2 billion years ago or whether they're much more recent. We won't see a volcano erupting. I'll buy you a pint if we do. It's very unlikely. But I don't think Mercury is completely dead.
Well, when you get there, come back and tell us what you find. Dave, thank you very much.
It takes decades to plan a mission like Bepi-Colombo, so it's great to see it finally leave our planet and head out towards its destination. It's made up of 3 main components: the transfer module, which will carry 2 orbiters, a planetary orbiter, and, encased in a sun shield for the journey, a magnetospheric orbiter. And what an extraordinary journey they've got ahead.
Even though the Earth and Mercury are never more than a short hop apart from each other in astronomical terms, getting there poses a unique challenge.
Bepi's transfer module, the bit of the spacecraft that powers the journey and carries the 2 orbiters, was built here in Stevenage by Airbus.
So what are the engineering challenges when you're sending a spacecraft to Mercury?
We have to be able to get it to Mercury, which is the most difficult place to reach in the solar system, and we have to make sure it survives when it gets there.
So let's take those problems one by one. In terms of getting there, why is it difficult to get to Mercury?
Because the sun is so big and has such a gravitational pull that if you do nothing, you're just going to end up right in the middle of our sun. So the trick is, how can you get to really close but not get caught by its gravity?
So how do you do that?
It's going to leave Earth, and in fact it's going to orbit the sun alongside Earth for a year and then do an Earth flyby, which will shoot it into the solar system. And then we will decelerate and we will do 2 flybys of Venus, and then we will be in the orbit of Mercury but not captured by it, and we have to do a further 6 Mercury flybys to slow ourselves down and slowly end up where we can just very gently end up in orbit around the planet.
So every time you go past the Earth, Venus or then Mercury, you lose energy and it slows the spacecraft down. That's the key.
Yeah, it's the key. It slows the spacecraft down, and then we have a really unique propulsion system on board, which is a plasma propulsion system, and that's going to decelerate us for a lot of the journey as well. And in fact, the power of these thrusters is that they operate in a pair, and one pair of thrusters has the force of a flapping canary.
But a canary that never gets tired.
It never
just
gets
keeps
tired
flapping.
and keeps going. Yeah.
Bepi Colombo will travel for 7 years before reaching its destination. In orbit around scorching hot Mercury, just 58 million kilometers from the surface of the Sun.
How do you keep the spacecraft cool so that it survives when near the Sun?
The thermal control system was really key for this mission. We've got multi-layer insulation around the outside. It's a series of blankets, and the outer layer is actually a ceramic material.
Makes me think of cups and saucers and things like that.
Exactly, but no, in fact, it's the same material, but it's in a sort of softer form, and it's going to reflect the sun. It can reach temperatures of 450 degrees C.
Wow.
There's a layer behind that can cope with 250 degrees C.
So how do you test a spacecraft that's going to such an extreme environment?
First of all, we have to make sure it will survive launch, which is the vibrations, and then we try and run through all the thermal conditions that we can. We can't do it under weightlessness, however, so there are some key elements that we've had to rely on modelling to know that they'll work.
So you can bake it, but until it's out in the real conditions in space, you won't quite know what's going to work.
Exactly. We've got very good thermal models that we create, so we're confident it will work, but we can't actually test some of these things until it's in orbit.
So it's not a coincidence that we're here talking about this. Some of the spacecraft was put together here in Stevenage. What's the UK's role in this mission?
Well, we had quite a big team here. We put together the whole of the satellite, the structure, so all the walls, the systems, the electrical parts. We had the Mercury transfer module here. We put in the chemical and the electrical propulsion system.
It makes me realise how long a process this is. It takes a long time to get a mission like this to the launch pad and then off into space.
We've had 16 countries involved in this in Europe. But also we changed the designs along the way. So the really early phase involved a lander, which was something that I worked on over 10 years ago.
Would have been nice to have a lander, wouldn't it?
It would have been really great. It was going to be just a small little thing to land in a shadowed crater so it would survive on the surface, but maybe the next mission.
Always the next mission. We can always come back.
If everything goes to plan, the Bepi Colombo transport module will insert its 2 scientific passengers into orbit on the 5th of December, 2025. And then the real work can begin. One of the mysteries that Bepi is hoping to solve is how the planet formed. To do this, ESA's Mercury Planetary Orbiter, or MPO, is carrying a raft of scientific instrumentation. One particular instrument, called MIX, may reveal what Mercury is made of and how it formed. The lead researcher for its operation is Emma Bunce. So Emma, thanks for coming to speak to us. Now, this is a model of MIX. What is MIX?
That's right. This is an exact full-scale replica of our instrument, which is flying on the Bepi Colombo mission to Mercury. So MIX is the Mercury Imaging X-ray Spectrometer, and it measures at X-ray wavelengths, so that's part of the electromagnetic spectrum. So it works a little bit like a camera, but it's working at a different wavelength.
So does it work as a standard camera? Because you have a lens and sort of the light comes through.
Not really. It's actually much more complex than that, and that's part of what's really neat about this instrument, actually. We're using a very special type of optic called a microchannel plate. And it's those channels that are capable of focusing X-rays or channeling X-rays into the system.
So why measure X-rays?
The X-rays coming from Mercury's surface actually tell us what the planet is made of. It gives us an elemental composition on the surface of Mercury at very fine detail. So what happens is an X-ray photon from the sun comes in, knocks an electron out of its low energy state in a particular atom and creates a gap. And then another electron will drop down into the gap and release energy as it does so.
And the energy it releases is X-rays?
Is an X-ray, a fluorescent X-ray, and that's what we measure, a fingerprint of the atom on the surface.
Knowing the chemical composition of the planet's surface is critical, because it may allow us to work out how Mercury formed. And there are several theories in play. So what will all this data tell us, and what do you hope to find out?
The composition of a planet tells you about the situation that was around in the protoplanetary disk as the planet was forming. So we need to try and build up a picture, the best picture we can, of the composition of the surface, and then we can learn about the formation processes for Mercury and how it's evolved over time.
So what are the current theories of how Mercury was formed?
There are some formation theories around, but at the moment, none of them are able to explain all of the observations that we have of Mercury. One is that Mercury has a very large iron core. That's something that's very unusual about Mercury. It's very dense. So the iron core takes up about 75% of the radius of the planet.
Yes,
so
that's huge.
Significantly bigger than the other terrestrial planets. And so that makes you think about what that has to say about the formation of the planet. So was it an orderly process, i.e., did it just happen to form in a very iron-rich environment?
So this is the accretion that sort of everything sort of falls in.
Yes.
Yes.
So a sort of pre-sorted protoplanetary disk that was very iron-rich and allowed Mercury to form in the way that we see it today. Alternative theories would say that something dramatic has happened in Mercury's history. For example, a giant impact where two bodies of similar size, one of them Mercury, collided and obviously blew off lots of the mantle and crust of both bodies, and then possibly those bodies merged together to create
leaving a
Mercury.
big iron crust. Oh, sorry, big iron core.
Exactly, leaving behind a larger than typical iron core. And then there are other theories, for example, hit-and-run theories, where a bigger object collides with smaller Mercury, and that could have happened multiple times, according to these different theories. Hopefully what we're going to do is give the theorists the best chance to come up with a formation scenario which will explain all of the observations that we have and give us a better picture of how that tiny planet in our solar system has formed and survived in its location so close to the sun.
So this was all designed and built here at Leicester?
Yes, the original principal investigator of this instrument was Professor George Fazer. And sadly, and very suddenly, he passed away in 2014, and that's when I took over the role as principal investigator of the instrument. But this is George's genius sitting in front of us.
So this is George's legacy, and it's going to be going
Absolutely.
to Mercury. Discovering just how Mercury formed is sure to be an eye-opener. Because up until now, no one knows quite how it happened. Later on in the programme, we'll be finding out about the planet's magnetosphere and what that tells us about Mercury today. But first, Pete reveals how this tiny planet can be seen without having to endure a long, cold night.
Mercury is a tricky planet to observe, and it's even rumoured that Copernicus went to his grave without ever seeing it. Now, one of the reasons why it's so difficult is its close proximity to the Sun. It takes just 88 days to complete one orbit, and because it's so close to the Sun, travelling around like that, it alternates from a morning object to an evening object continuously. But morning or evening, Mercury is never found more than 28 degrees either side of the Sun. And a site like this at Old Winchester Hill in Surrey, with its flat, unobstructed southern horizon, is perfect for viewing it. though clouds, of course, are always getting in the way. If Mercury is in a good position relative to the Sun, you should be able to spot it about an hour before sunrise or after sunset. But binoculars or a telescope will make the job a lot easier. Use online resources or apps to help locate it. And what you should see is Mercury appearing as a pale pinkish dot. But if you want to take a photo of it, there's a problem. The dense atmosphere wobbles and judders the view. So if you want to get a sharp shot of the planet, the best time to do it is during the day, when it's at a much higher altitude. Now, the problem with trying to find Mercury during the day is that it isn't easy to see. So you've got to use something as a navigational guide. Now, there aren't many stars visible easily during the day, but there is one, and that's the Sun. What we're going to do, we're going to use the Sun as our navigational reference. We're going to set the coordinates of our telescope to the Sun and then use that to move off to the coordinates of Mercury. Of course, you'll need to protect your equipment and, more importantly, your eyes by fitting a certified solar safety filter to your telescope. I'd recommend creating your own, and there are full instructions on how to do this on our website. Okay, so I've got the telescope now pointing at the Sun. I'm just waiting for the clouds to clear out of the way to just do a fine precision adjustment. And then once I've done that, I'm going to move the telescope round to the coordinate position of Mercury so that the setting circles read that coordinate position. In that position, I should be able to take the solar filter off, and hey presto, Mercury should be, in theory, in the centre of the field of view. Fingers crossed. Well, the clouds are coming and going, but I have managed to find Mercury. It's right in the centre of my field of view. There it is, just shining away there. And I can tell you, it's really satisfying to find a planet in the daytime sky. Finally, one for the calendar. On Monday, the 11th of November 2019, Mercury will transit or appear to pass in front of the Sun. A relatively rare occurrence, and one that will make it much easier to view the planet. So you've got about a year before the next transit of Mercury, and if you miss that one, the next one isn't until November 2032. So don't say you weren't warned.
BepiColombo isn't just investigating the origins of the planet and the solar system. It's also attempting to reveal what's going on with Mercury today. Messenger's measurements of Mercury's magnetosphere suggest strange things are at play. And this may reveal what's happening inside the planet. One of the team that worked on Messenger is now just as involved with BepiColombo, Susie Imber. So, Susie, the planet Mercury has a special significance to you. Can you tell me about that?
Yeah, I've spent most of my scientific career studying Mercury. So I happen to be working at NASA at the moment when their spacecraft arrived at the planet Mercury in 2011.
That's good timing.
It was good timing, accidental. And so I've been working on it for the last 7 years. So it's going to make up a good portion of my whole career, I think, by the end.
So Mercury's magnetosphere is quite different from what we usually find. So why is it so interesting?
Yeah, it's a very strange, anomalous planet in terms of its magnetic field. So its field is weak. It's about 100 times weaker than the Earth's magnetic field. It has a big iron core, but it rotates very slowly, the planet, and so its field is not very strong. And the magnetic field is offset to the north of the planet. So you would normally expect your magnetic field to be centered on the middle of the planet.
So how will Bepi sort of improve our knowledge?
Well, Messenger's orbit was interesting. It went very close to the north pole of the planet and then very far away from the south pole of the planet. And so we know a lot about the magnetic field on the northern side of the planet, but not much about the southern hemisphere. And because the field is offset to the north, That means that the interaction of the particles with the surface, which is guided by the magnetic field, is going to be quite different between the north and the south. And we've never had a chance to measure the south before. So we're going to find out some quite interesting information with Bepi Colombo.
But how do we measure it? What instruments are on board Bepi that will allow us to measure it?
Both of the Bepi spacecraft, so this is the Japanese spacecraft and the European spacecraft, have instruments to measure the magnetic field. So they're magnetometers. They are on a boom far away from the spacecraft.
Oh, so it doesn't get the magnetic field from the spacecraft?
Exactly. The other instrumentation that we need is instruments that measure particles, so ions and electrons. So we have instruments on board both spacecraft to measure ions and electrons. And with those pieces of information, we can piece together a lot about the dynamics of Mercury.
Does that give us any indication of what's happening inside the planet, inside the core?
Well, it sets a really big technical problem for all those dynamo scientists out there who are trying to make theories to produce a magnetic field that looks like Mercury's. Analysing the magnetosphere is how we worked out that the magnetic field was offset. All we can do is look at what we can see outside the planet and try to infer what could happen inside. And yeah, the best way is to understand the magnetosphere, yes.
But it's not just the secrets of Mercury's interior that Bepi might reveal. Activity on the sun's surface generates space weather. And studying its impact on Mercury's magnetosphere may also help us here on Earth.
Space weather at Mercury is extremely dynamic. We have much more severe space weather at Mercury than we do at the Earth because it's got a weak magnetic field and because it's close to the sun. So a combination of those things lead to extreme space weather events. Analogous to the worst ever space weather event that has ever happened on the Earth, which happened in the 1850s, the Carrington event. And so we see that sort of magnitude of event at Mercury every day.
Wow. The Carrington event of 1859 was a coronal mass ejection that caused vast, brilliant aurora across the Earth. Back then, it was a spectacular light show. But when this violent electrical phenomena occurs again, it could cause devastation to our power grids and communication satellites. Bepi Colombo could lead to a far deeper understanding of the danger.
Bepi Colombo is a 2-spacecraft mission, and the real beauty of that is that we might have one spacecraft looking at what's coming from the sun and the other spacecraft looking at the impacts on the magnetosphere.
Measuring them both together at the same time.
And that's never been done before. We've never sent 2 spacecraft to be orbiting another planet. So if I can understand the physics of what's happening at Mercury and how that space weather is evolving and the physics behind that, I can apply that knowledge to the Earth. It's really going to get to grips with those questions, cause and effect, to do with space weather.
Susie, Mercury is a fascinating planet. Thank you for sharing your knowledge with us.
Thank you.
Bepi is now more than 10 million kilometres from Earth and 18 months from its first planetary encounter when it swings past us in April 2020.
We wish it luck. And I can't wait until we start getting that data when it reaches its destination in 2025.
Me neither. And in the meantime, do come and see its twin here at the Science Museum.
Next month, I'm off to California for a date with Sophia. A 747 has been converted into the largest airborne observatory in the world.
Thanks for watching.
Good night.
The future is here, so what did tomorrow's world get right? For one night only, it's back on BBC4 live Thursday night at 9.